In this video, we will learn to find the sample size required to achieve the given margin of error. Find the sample size required to achieve the given margin of error. Round your answer to the nearest whole number. Alright, we're talking about margin of error, but we are not given some kind of a confidence interval or anything like that. So we're not given, we are 95% confidence. Nothing like that is mentioned. For that reason, we will be using this margin of error formula, just 1 over the square root of n. We only use this margin of error formula when we are given a specific level of confidence, like we want to be 95% confident. So we have to use a z-score, and we'll wind up using the standard deviation. But if none of that is mentioned, we just use this. Okay, so we're given the margin of error. So the margin of error is going to equal 1 over the square root of the sample size. And we're looking for the sample size, so we're looking for n. Now we can't just plug in 1.8 because this formula gives us a decimal, not a percent. So we need to convert this to a decimal by moving the decimal point twice to the left. So 1.8% is the same thing as 0.018. So that's what we have here. Now we've learned that we can swap these two things. Alright, the denominator and the number that's out here, those can be reversed anytime we want. So if we do that, then what we're going to get is I'm going to have the square root of n is equal to 1 over 0.018. Alright, this is a little bit close. See if I can move that over. Alright, and to get rid of the radical, I'm going to square the left side. So that means I'm going to have to square both sides. So if I do that, that should give me my final answer. So of course that'll just give me the n that I'm looking for. So I just need to square this. 1 over 0.018 squared. Alright, so I get 3086.4. Now when we're doing sample size, we are going to round to the nearest whole number. So 3086, that's it. Okay, let's do that again right here. Again, if I move that decimal point over twice, I'm going to get 0.029 is going to equal 1 over the square root of n. Swapping these is going to give me the square root of n is equal to 1 over 0.029. We will go ahead and square both sides like we did before. Okay, so that'll get rid of the radical. So 1 over 0.029. Alright, so 11,089. I said that wrong. It's not 11,089. It's 1,189. And that's how you find the sample size required to achieve the given margin of error.